Hello, prob stats. This is 6.5. This is the last part of chapter 6, and it's about assessing normality. We have been doing this for a while. We have been looking at our curves to make sure they're normally distributed. We've looked at our lines to make sure there's no weird patterns. We're also going to talk about one more, which is the Reiner-Joyner distribution, our assessment of normality, and it's also on StatDisk, which you'll like. All right, so we're going to examine histograms for outliers, normal quantile plots to determine whether the data appear to be from a population. All right, requirements for a normal distribution. First, you have to visually inspect the histogram. Is it a rough bell shape? It doesn't have to be exact, but it has to be rough. We have to look, are there any outliers? And we're going to look at our normal quantile plot. And all of this will be done on StatDisk. Okay, remember this normal quantile plot is a graph of points. All right, X value is the original set and Z score is what's expected. Now, when we look at these things, we're going to determine whether it's reasonable to assume that the data is from a population with a normal distribution. Histogram. So we construct the histogram. Actually, StatDisk is going to do this for us. Is it normally distributed? Outliers. Can you identify them? Is there more than one outlier present? Okay, conclude the data might not have a normal distribution. The normal quantile plot, if the histogram is basically symmetrical and the number of outliers is 0, 1, okay, we're going to use our StatDisk to find our normal quantile plot. And remember, it has to be relatively close to that straight line, like this. All the dots have to be here. And there can be no pattern, like it cannot be a pretty little wave. That's bad. We're going to look at these criteria to see if this works. Reasonably close to a straight line, we just talked about this, and no weird pattern. Not normal, it's the exact opposite. They're not close to a straight line, and there is some kind, or there could be a weird pattern. It's one or the other. It doesn't necessarily have to be both. All right, so now let's look at our curve. We look at our histogram. It is normal, right? It's not a perfect bell shape, but it's pretty darn close. We're happy. It's reasonable. We're good. Normal quantile plot, no weird shapes, close to a line. We're happy. Both check. All right, this is a normal distribution. We agree. Let's look at the next one. You try it. Not a bell shape. Look at this. This is a uniform distribution. So not a bell shape, misses step 1. And if we also look at our normal quantile plot, we see this lovely little wave, which also is bad. So it fails both. Not a normal distribution. Okay, look at your next one. What do you think? I hope you realize this guy is absolutely skewed right. So he's skewed right, and look at all this here. All this data over here, definitely not a straight line. Fails both, not a normal distribution. Okay, so we are unhappy with everything. Now, the Ryan-Joyner test is also from our thing, and it will tell you if the number of potential outliers is there, and if we should reject or accept the null. Now, let's look at Old Faithful. I think we'll actually go to StatDisk and do this, just so you can practice a little bit. All right, go to your StatDisk, go to your data sets. Remember, we're in the 13th edition. Old Faithful is number 23. All right, so once you found Old Faithful, we're good here. Go to Data, do Explore Data. And we want to do, I think it was duration, if I remember right. Okay, and it is duration, right? So go here, click on duration time, and evaluate. Now, if you look at your histogram, it is not normally distributed. If you look here, it definitely looks like it has outliers right here. See these outliers? We don't like those. And because of those outliers, we now have it kind of left skewed. So it is not a normal distribution. Now, we look at our box plot, which is there, also looks left skewed. Now look at our data. All right, not close to a straight line. It's definitely kind of following a curve, also not left skewed. Now, let's go up here. Okay, I'm sorry, I told you to type the wrong one. It's not descriptive statistics, it's normality assessment. All right, also duration, again, we want to do the same one. Now, we get the same thing. All right, we still have our histogram down here, which is the same thing, and we still have our normal quantile plot. But up here, we have a Ryan-Joyner test. And when we look at here, we have a critical value of 0.04. Right here, it says, if you look at the second line, if you're looking right here, I'm hoping you can kind of see where my thing is. Reject normality with a 0.05 significance level. It rejects both times. This is saying we do not have a normal distribution and it must be rejected. It does not work. All right, I want you to use your data set and try body temperatures at 8 a.m. Okay. 13th edition, body temperatures, 8 a.m. So select 8 a.m. and evaluate. Okay, when you look through our data, okay, the Reiner-Joyner says fail to reject normality. That means it should be a normal distribution. Now let's look at our histogram to see if this is what we see. And we do see a fairly normal bell shape. It's very rough, but it is a bell shape. And if we look at our normal quantile plot with our z-scores, it is also following a line. We are happy. This is a normal distribution. We can use our data. All right, good luck with your homework. I hope you do well. You should be on page 281. And then the next part is a summative project. This is almost a test this time. So I hope you have fun and enjoy this, and make sure you post questions if you have any.